Okay, so in this tutorial we'll be covering more advanced algebra. Algebra, as you all know, is basically numbers and letters. Anything with a number, let's say 3x plus 2y. This is an example of addition of algebraic terms. So anything with a number and a letter, or to be more precise, when you're multiplying anything with a numerical value like 3x into 2y. So something like this is a product of algebraic expressions, and this over here, this is a monomial or monomial, however you want to call it. This is a monomial as well, and basically we're finding the product, which means we're multiplying both of them. In this case, what we're going to do is we're going to multiply the numbers. So 3 times 6, or 3 times 2 is 6, and then we're going to find the product of literal factors, which is xy. So this is 6xy. Okay, now let's do a more complicated sum over here. Let's go. Let's try this one. Negative 3 square x into 6 h squared. Now this is an example, again, multiplication of monomials. What you're doing is first we're multiplying these numbers over here, okay, and then we're going to multiply the literal factors. So when we're multiplying the numbers, this is going to be negative 18 okay, 6 times negative 3 is negative 18. H squared into h is h cubed, and this is x cubed. Okay, so negative 18 h cubed x cubed is my final product of these two algebraic expressions. Okay, let's take another example. Let's take 5 into 4h minus 6k. Again, we're multiplying the numbers first. This is going to be 20, and then my literal factor, which is h, minus second term 30 times my literal factor again, 30k. So this is the product that I get, okay, for these two. Again, one more. So you have 6 e squared b into 5 e squared b is 9b squared. Here again, my numbers. So 30. This is a raised to 4. 2 plus 2, we added the exponents. So a raised to 4 b minus 42 a cubed b squared minus 54 a squared b cubed. Okay, since the variables or the literal factors are not the same, we can't go on and multiply these anymore. So this is the final product for this expression. Okay, let's move on to more complicated algebraic expression. This time is going to be polynomials by polynomials. So unlike a monomial, a polynomial has two algebraic terms in it. So you have y raised to 4 minus y squared. Now this is an example of a polynomial. Okay, now if I want to get a product of polynomial, okay, I'm going to repeat the same thing that I did in a monomial. Basically, I'm going to get the numbers to get to multiply the numbers together, and then multiply the literal factors after, and that's how I'm going to find the product of polynomials. Okay, so 4 y squared 2y 5 plus y cubed. So let's add them up like we add up other expressions. So y raised to 4 minus y squared plus y raised to 5 plus this is y cubed. Okay, so this is going to be y4 plus 5 is y raised to 9 minus y plus 5 minus 5 plus 2 is 7, so minus y raised to 7. Then my second term over here, so y3 plus 4 is y raised to 7 minus 3 plus 2 is 5. So my final answer, so I'm going to bring it over here, is 9 plus 7, y raised to 16 minus 7 plus 5 is y raised to 12. So this is the product that I get when I multiply these two expressions. Okay. Now let's move on to my next polynomial. Next polynomial is m plus 5w into 3m minus 7. So this is 2 into 3, which is 6. So I'm going to write it down, 2m plus 5w plus 3m minus 7. So this is 3 times 2, 6. Okay, multiply these two together, 6m squared plus first term or the second term, so 515 mw, then minus 7 into 2 is minus 14 mw plus 35w squared. 7 times 5, 35 w squared. Notice how they are arranged from descending order, so the variable with the largest exponent comes first, then you go on and you arrange them in the way that you get the exponents sorted out. So over here, this is a simple calculation, 6m squared, 6m squared plus 15 minus 14 plus mw. And this is 5 times 7. This is, I apologize, this was a subtraction over here because 5 times 7, 35. There's a negative sign over here. So this is negative 35. Okay, so that's basically how you multiply polynomials and monomials or monomials. We also have algebraic products where we have to deal with brackets. Okay, so let me give you an example of a bracket. A bracket polynomial. So you have a minus square bracket minus. Okay, so what we're going to do in this bracket, in an algebraic expression that involves bracket, any calculation, if you want to do any calculation, we're going to start from the innermost bracket. So I'm going to leave this one outside as it is. This bracket is as it is. This remains as it is. I'm going to try to solve for this bracket first over here. So this becomes minus 2a plus 2b plus or negative 2c minus 2c okay, so this is a c so a minus 2a is negative 8 plus b plus 2b is 3b, and then c minus 2c is negative c. this is B minus C minus plus A minus 3B plus C. So A minus C plus C cancels out. B minus 3B is negative 2B plus 8. And when you take this out, this and this cancels out, so we're left with 2B as my answer. Okay, so that's basically brackets. You start with the innermost bracket. In this case, we started out with this bracket, and then we gradually moved on to the exterior brackets, and finally we removed all the brackets and we simplified all the expressions, or all the lateral factors. Okay, that's for the calculations. Let's move on to a more practical example. Okay, this will involve perimeter. Okay, if you're calculating perimeter of a certain object, or a certain space, let's say a foundation. So let's move on to perimeter. I have a rectangular box that looks something like this. Okay, and I've been told that this is my B and this is my A, as well as this over here is my X, and this length over here is my Y. So now I'm told to find the perimeter outside this shape. So basically my perimeter is going to be, I'm going to add up all these variables to find my perimeter. So to start off with, I start off from here, so I have my X. Again, my perimeter, this outside space over here, that's my perimeter. In a regular case, my perimeter of a rectangle would be 2L, or 2 times length plus 2 times width. So this plus this plus this plus this. This would be my perimeter, 2 length, 2L plus 2 width. But in this case, since this is an odd figure, it's not exactly a rectangle, we are not going to use that formula. Instead, we're going to start adding up all the variables, or the lateral factors. So you have X plus this space over here is Y minus B. So Y minus B plus A plus B plus X minus A plus Y. So let's add these together. You have X plus y, then remove the brackets, minus b plus a plus b plus x minus, again removing bracket, x minus a plus y. So my x and x is 2x plus y is 2y minus b, and plus b cancels out, plus a minus a cancels out. So basically we're left with 2x plus y. Okay, this is my perimeter of this shape. Again, this is my P of this shape. Okay, now let's move on to my next example. My next example is a shape and form of a T, and given the dimensions, we are told to calculate the perimeter of this T. So this T looks like something like this. So this is my T, and I've been told that this space over here is my X. Okay, this is my A. This entire thing is my X. This is 3A. This over here is A, and again this over here is 3A. So I'm going to do the same thing as we did in the other calculation. If this was a rectangle, or if this was a square, it would be a rectangle 2x. Basically, it will be x plus x to find 2x plus 2x to find the perimeter. But this is not a square or a rectangle, so we're going to start adding up the sides together, and hopefully make this into an algebraic expression, a calculation that involves algebraic expressions. Okay, so you have starting off with a plus this side is x plus a again plus 3a plus, now this is the tricky part, this is entire length over here is x minus this a over here to get this part, so plus x minus a plus a plus x minus a again plus 3a. Now again, we're going to remove all the brackets to simplify our algebraic expressions. So we have a plus x plus x.
So I have a plus a is 2a plus 3a is 4a minus a is 3a plus a is 4a minus a is 3a plus 3a is 6a. 6a plus x is 2x plus x is 3x. So I have something like 3 into 2a plus x. So that's basically how you use algebraic expressions, or add, multiply, divide, define perimeter of given shapes, objects, space, etc. There are a lot of practical applications of algebraic expressions. They're used in angles, triangles, trigonometry, quadratic equations. It's all over the place. So that's basically it for this tutorial.